Hello, everyone. Today, I would like to give you a lesson on the topic cone. Before starting to watch this video, don't forget to subscribe to my channel and like it. I will be very grateful to you for that. So, we see a right-angled triangle in front of us. What geometric body will be formed if we rotate it around its larger leg? And this geometric body will be a body called a cone. A cone is a geometric body consisting of a flat base, usually round, and a side surface that tapers to a single point, the cone's vertex. Here are the most interesting cones in front of you. So, the axis of a cone is a straight line that passes through the vertex of the cone and the center of its base. Here you see that the line OA is the axis of the cone. A cone has only one base, which is a circle. OB is the radius of the base. And pay attention that OA is also the height of the cone. The generator of a cone is a segment connecting the vertex of the cone to any point on its base circle. Here you see that AB is the generator of the cone. The axial section of a cone is a plane that passes through its axis. That is, we conventionally took a cake and cut it in half. The volume of a cone is calculated using the formula V equals 1/3 times pi times r squared times h, where V is the volume, r is the radius of the base of the cone, and h is the height of the cone. The formula means that the volume of a cone is equal to 1/3 of the product of the area of its circular base and the height. The lateral surface area of a cone is equal to the product of the number pi, the radius of the base r, and the length of the generator L of the cone, which is written by the formula S lat equals pi r L. I can prove to you why the area of the lateral surface of a cone equals PRL. Well, first of all, from the lateral surface of the cone, we will have a sector of a circle. And in this case, the generator of the cone will be equal to the radius of the circle, so the radius of the circle is L. And let's remember that the length of the circle L is equal to 2 pi r. I will mark the length of the sector in black. Now let's find the area of this sector, which I have signed in purple. So the area of this sector is equal to half the product of the length of the sector by the radius. The radius in our case is L, and the length of the sector L equals 2 pi r. So let's substitute this, and remind ourselves that the area of this sector is equal to the area of the lateral surface of this cone. So after substitution, we will have this formula, and finally, after we cancel the 2's, we will have the formula for finding the area of the lateral surface of a cone. Problem 1. And so we see that we are given a formula for finding the lateral surface area of a cone. We are also given a generator, which is 10. We are given a diameter, which is 14. So let's first find the radius of this circle. It's half the diameter. We plug everything into the formula for finding the lateral surface area, and it's going to be 70 pi. Consider the second picture. Here we see that our circumference is 26 pi, given the generator, which is 25. First, using the formula for finding the circumference of a circle, we must find the radius of the circle, which is 13, and then we must find the area of the lateral surface of the cone, which will be 325 pi. Problem 2. Determine the volume of the cone using the given data. So we already have a formula. We are given the height, we are given the area of the base of this cone, and now we need to find the volume of this cone. We substitute all the known quantities into the formula, and get that the volume of the cone will be equal to 152. Let's consider the second case. Here we are given the height and the generator. So by the Pythagorean theorem, we can find the radius of the circle, which will be equal to 6. And then we will substitute the unknown quantities into the formula for finding the volume of a cone, and the volume will be equal to 96 pi. Problem 3. The axial section of the cone is an equilateral triangle ABC. The distance from the center of the base of the cone to its generator is 20 square root of 3. Determine the area S of the total surface of the cone. In response, write down the value S divided by pi. Solution. So let the equilateral triangle ABC be an axial section. I will immediately denote the segment OM, which is given to us by condition. This segment will be perpendicular to the side BC, because OM is the midline of the triangle ALC. And why will it be the midline? Because first of all, this is an equilateral triangle. So AL will be not only the height, but also the bisector and the median. And the median divides the triangle into two equal triangles. So LM will be equal to MC, and AO is equal to OC already by the condition of the problem. So AL by the property of the midline will be twice as much as OM. So the height of an equilateral triangle is 40 square root of 3. Since AL is both the height and the median, and this triangle is also equilateral, so let LC be equal to A. AC will be equal to twice as much, equal to 2A. Let us recall the Pythagorean theorem, and by the Pythagorean theorem we can determine that side A is equal to 40. And I have already drawn this cone in front of you, in which I wrote and marked what the radius of the base is, and what the generator of the cone is. Next, we find the lateral surface area of the cone using the given data, and then we will find the area of the base, which is equal to 1,600 pi, and we will substitute the found values into the original formula, and we will have that the area of the full surface of the cone is equal to 4,800 pi. But our answer is 4,800. So if you understood everything today, I would give you Boeing 746-8 VIP as a gift. If you are worried or excited because you didn't understand something, no problem. Watch this video again slowly. Never give up, and I wish you to understand it as soon as possible. Bye.